Hi friends, this is Naresh. In this class I am going to explain about engineering drawing, and today's topic is involutes. In this class I will explain how to construct the pentagonal and hexagonal involutes. Now coming to the problem, draw the involute of a pentagon of side 25 mm, and draw tangent on normal at any point M on it. Okay, here in given data the side of a pentagon is 25 mm. So first of all you have to construct a pentagon of side 25 mm. So here each side is 25 mm. So the number of sides for pentagon is 5. So therefore the total length or circumference of this pentagon is number of sides into length of the side, that is 25 into 5, totally 125. So 125 is the circumference of a pentagon. Here ABCD is the corner points. Now you have to draw tangent lines from point A, point B, point C, point D and point E as shown in figure. Now the length of AE equal to 25 mm. So here with A as center, here A as center and radius equal to AE. Okay, AE as radius. Okay, AE as radius and with the center A as center. Draw an arc to cut the line AB produced at point P1. Okay, this is the point P1. Here the length of AE equal to AP1. Okay, AP1 equal to 25, AE equal to 25. In similar way, B as center and BP1 as radius. Okay, BP1 as radius. Draw an arc to cut the line CB. Okay, here B as center and BP1 as radius. Draw an arc to cut the line CB. Here the length of BP1 from point B to P1, the distance is 25 plus 25, total value is 50. So here the radius is 50 mm. Okay, here BP1 equal to BP2, that is 50 mm. Okay, similarly C as center and CP2 as radius. Okay, C as center, CP2 as radius. Here from here the distance between point C and P2 is 75, because this is from here to here the length is 25 and the length of BP2 equal to 50, BP1 equal to BP2, so it is 50 plus 25, that is 75. Here the radius of the radius of arc CP2 is 75 mm. Now C as center and CP2 equal to 75 mm as radius. Draw an arc to cut the line CD at point P3. Okay, here also the radius of CP2 equal to CP3. Okay, CP3 equal to CP2 equal to 75 mm. Okay, here this point C is the center of this arc P3 and P2. Now similarly D as center, DP3 as radius. Here the value of CD equal to 25 plus the length of CP3 equal to 75. So the total radius is 100 from point D to P3. The radius is 100. In next step, D as center and DP3 equal to 75 plus 25 equal to 100 mm. 100 mm as radius, and draw an arc to cut the line ED produced at point P4. Okay, in similar way E as center, EP4 as radius, draw an arc to cut the line AE. So here the length of EP4 equal to 125 mm. From here to here the length of ED equal to 25 plus length of DP4 equal to 100. So the total radius is 125 mm. So E as a center and EP4 equal to 125 mm as radius, draw an arc to cut the line AE produced at point P5. Okay, this is the point P5. This is our required shape of an involute. And now you have to draw a tangent and normal at any point on this involute. Okay, you have to draw a tangent and normal line at any point on this involute. So here I consider a point M. On the arc P4, P5. Okay, here I consider the point M here. Okay, this point M lies on the arc P4 and P5. Okay, the center of this arc is capital E. E is the center of this arc P4 and P5. So you have to join these 2 points to obtain the normal line. Okay, join point E and M, extend it, which is our required normal line at point M. Okay, this is our required normal line at point M. Similarly, at point M, draw a perpendicular line to the normal to obtain the tangent. So here you have to draw a perpendicular line to the normal at point M. This is our required tangent line. So this is our required normal line. This is our required tangent line. This is the final answer for pentagonal involute. Okay. First of all, you have to construct a pentagon of side 25 mm and draw tangent lines at A, B, C, D, and then after you have to take A as center and AE as radius, draw an arc. Then after B as center, BP1 as radius, draw an arc. Then after C as center, CP2 as radius, draw an arc. Then after D as center, DP3 as radius, draw an arc. And finally capital E as the center and EP4 as radius, draw an arc. Okay, this is the procedure for to construct the pentagonal involute. Okay, now coming to the another problem. Draw the involute of a hexagon. Draw the involute of a hexagon of side 25 mm and draw tangent and normal at any point M on it. Okay, here you have to construct a involute for hexagon. The side of hexagon is 25 mm. Okay, here number of sides for hexagon is 6. So the circumference of hexagon, the circumference of an hexagon is equal to length of the side into number of sides. So length of the side 25 mm into number of sides 6. So 25 into 6 is the circumference of a hexagon. Now first of all you have to construct a hexagon A, B, C, D, E, F. Then after you have to draw tangent lines from point A, B, C. Okay, you have to draw tangent lines from point A, B, C, D, E, F. Okay, you have to draw tangent lines from all points. Then after A as A as center point and AF as radius. AF as radius and draw an arc to cut the line AB. Okay, once again I repeat. A as center, AF as radius. Draw an arc to cut the line AB. Okay, produced at point P1. Okay, this is the point P1. Here the length of AF equal to 25 mm. Therefore the length of AP1 also 25. Okay, AF equal to AP1 equal to 25 mm. Next you have to consider B as center, BP1 as radius. The radius of BP1 equal to 25 plus 25. Okay, total 50 mm. 50 mm you have to take radius. Okay, B as center, BP1 equal to 50 mm. 50 mm as radius. Draw an arc to cut the line BC. Okay, you have to cut the line BC at point P2. Okay, similarly here you have to consider C as center, CP2 as radius. Here the length of radius CP2 equal to 25 plus 50, that is 75 mm. Here the radius of CP2 equal to 75 mm. Okay, you have to consider C as center and radius equal to CP2 equal to 75 mm. Draw an arc to cut the line CD. Okay, to cut the line CD and produce it at point P3. Okay, now similarly D as center and DP3 as radius. Draw an arc. Here the length of DP3 equal to 25 plus 75, that is 100 mm. So the radius, the value of DP3 equal to 100 mm. So D as center and dp3 equal to 100 mm as radius. Draw an arc to cut the line D. Okay, produced at point P4. Okay, here dp3 equal to dp4 equal to 100 mm. Now consider capital E as a center and EP4 as a radius. Draw an arc. The value of radius EP4 equal to 25 plus 100, that is 125 as radius. Okay, E as a center and EP4 equal to 125 mm as radius. Draw an arc to cut the line EF. Okay, produced at point P5. Okay, now similarly F as a center and FP5 as radius. Okay, FP5 as radius. Draw an arc. Here the value of EP5 equal to EP4, that is 125. Now EF equal to 25. So the length of FP5 equal to 150. Okay, so F as center and radius equal to FP5 equal to 150 mm. Draw an arc to cut the line AF. Okay, produced at point P6. Okay, this is our required shape of an involute. Okay, then after you have to draw tangent or normal at any point on this involute. So I consider the point M on arc P5 P6. Okay, I consider the point M on arc P5 and P6. Okay, this is the point M. The center of arc P5 P6 is point F. Okay, point F is the center of the arc P5 and P6. So you have to join the points F and M, which is, now I am joining the point F and M and extend the line, which is the required normal line. Okay, which is the required normal line at point M. Okay, this is our required normal line at point M. Similarly, at point M, draw perpendicular line perpendicular to the normal line. Okay, draw a perpendicular line to the normal to obtain the tangent line. Okay, this is our required tangent line. Okay, this is our required tangent line, this is our required normal line. This is the final shape of hexagonal involute. Okay, here from the distance FP6 is called circumference of the hexagon. So the length of the circumference equal to FP6, that is equal to number of sides into length of the each side. Okay, that is 150 mm. Okay, FP6 is the circumference of a hexagon. Thank you one and all.